So, you had a chance to write this, yes? You can only multiply two roots together if they have the same index. Because, you know, we live in a world of zero tolerance. A cube root can't mix with the square root. That just doesn't work in today's society. A cube root can multiply with a cube root, or a square root can multiply with a square root, or so on and so on. So just so I know we understand, open up your books to page 238. I don't think there is. All right, anyway, so take a look at 238. Problem 1, got it? You don't have to try to simplify anything. All you got to say is it possible? So take a look at problem 1, got it, part A. Is it possible?
Yeah.
Why not?
Yeah.
Different indices. If one's a fourth root and one's a, what, a fifth root? Just not possible. You guys see what I'm saying? But what about part B on problem 1, got it?
Yep.
That one is possible. And what would the answer be? Look at this property here. If you're multiplying two radicals that have the same index, you just multiply the stuff on the inside. So negative 2 times negative 5 would be 10, so it would be the fifth root of 10 would be the answer on that one. That's not so hard, is it? There's actually a little bit of background we need to do before we actually start multiplying. We need to talk a little bit more about simplifying just one single radical. So let's start right here. We're not going to be multiplying things just yet. I would really rather not see anybody in here drawing those goofy little number trees underneath any of these numbers anymore. That is junior high way of doing mathematics. Okay? But it won't with what we're going to be doing a little bit later. Okay? So we need to become a little more sophisticated now. You ready? Can you handle it? I'm not saying it's an incorrect method. It just doesn't work for what we're going to do. Okay? So, what numbers can you square root? 12, obviously not. But what numbers can you square root? 4, 9, 16, 25, right? Any of those numbers divide into 12? 4. So I want you to write this. 12 is the same as 4 times 3. Now, why specifically 4 times 3? Why not 6 times 2?
Because one's not a square root.
1 has to be a square root. Neither 6 nor 2 are square root numbers, so it has to be 4 times 3. Now, we're actually going to use this property in reverse. Instead of going from here to here, we're going to go from here to here.
I take the 4 out of it.
So you can write this as two different square roots. Square root of 4 times square root of 3. And square root of 4 is 2. So the answer is 2 times square root of 3. Now I know you could have gotten that answer by drawing those goofy number trees underneath, but this is how every single textbook, math textbook, teaches this property, because this is the best way to do it. So let's do it with the cube root now. So you're probably not as familiar with cube root numbers, but we're not going to use a 4, a 9, and a 16 anymore because those are square root. Perfect squares. We need perfect cubes. What kind of numbers have cube roots? 9 has a square root. We need cube root. 8, or 27, or 64. Do any of those divide into 24? 8. So now we do the same process. We're going to change this into the cube root of 8 times 3. And that just changes into the cube root of 8 times the cube root of 3. And what is the cube root of 8?
changes into 2 times the cube root of 3. Now, just so we can get rid of all the misconceptions that I've seen over the years, a lot of students will see a 3 here and then see a 3 here and say, hey, something's got to simplify there. 3 and a 3. They match! Can you take a cube root of 3? No. Okay? Just like you can't take a square root of 3. Anyway, your calculator for the most part isn't much help on these. If you type in like the square root of 12, it's not going to simplify it for you. It just tells you what the decimal is. But if you want to figure out if your answer is right, you could type in your answer, 2 times the square root of 3, and what should you get? Yep. So at least you can check your work to make sure your answer matches what you started with. But other than that, your calculator is not much help on these problems. So let's move past numbers and go back one more time to variables. What happens when you have variables with exponents? Come on, we just barely talked about this like 10 minutes ago. Divide the exponent by the index, and we're going to get x to the 7. Absolute value? No, because we took an odd root. So the question was asked, and it's a good question, what if the exponent doesn't divide by the index? That's a very good question. So let's take a look at this one. So obviously 23 doesn't divide by 3 evenly. Right? So what we have to do is something along these lines where we split it up. So we need the next smallest number smaller than 21 or smaller than 23 that is divisible by 3. The next smallest number. So let's go with 21. So I'm going to change this into the cube root. Instead of x to the 23rd, I'm going to split it up into 2 different x. And x to the 21. And then how many more x's do I need? So then it's going to be x to the 2nd.
If you add it, it would be 2x. If you multiply it, you just combine the exponents. How many x's total are there? There's 21 here, and there's 2 here, so total there's 23. So it's the same thing we started with. I just split it apart. Why 21, specifically 21? Because it divides by 3. Now let's do the same thing. Split this up into 2 roots. So do the cube root of x to the 21st times the cube root of x squared. So now what are we going to get? What is the cube root of x to the 21st? X to the 7, right? 21, last time I checked, 21 divided by 3 is 7. So this term right here just changed into x to the 7th. What about the cube root of x squared? Just stays the cube root of x squared. If your exponent is smaller than the index, there's nothing you can do with it. It just stays inside.
This process that we just did is the same process that we did with numbers. Now we're just doing it with variables and exponents, but it's
Not any different of a process. Questions before we move on? What do you do if the exponent is smaller than the index?
Leave it inside.
You leave it inside. If the exponent is bigger than the index, but it doesn't divide, you've got to split it up. Like this. So let's take a look at this one. Square root of 50
Times x to the 11th.
Well, we're going to do this one piece at a time. Let's first deal with just the coefficient, the 50. 50 does not square root. All right? We break it up, exactly, just like we did with the 12 or the 24 here. What? It's 25. Why not 5 and 10?
5 and 10 multiplies to 50. One of them is not a square root. One of them has to be
A square root. So you're absolutely right. We're going to use 25 and 2. Now we deal with the variable.
X to the 11th is a problem because 11 is not divisible by 2.
10 and 1.
So we need the next smallest number that is divisible by 2. X to the 10th. And then that means we have an x to the 1 left over.
That's an x to the 10th. Yep.
What do you suggest we do now? We've kind of split this up in a nice way. Which one of these terms can we simplify? The 25 and what other one? X to the 10th. So those are going to move out to the front. So what is the square of 25? So I'm going to move a 5 out here.
5x to the 5th.
And then the x to the 10th becomes x to the 5th.
Root 3.
And then the 2 and the x have to stay on the inside. Because those don't simplify. Exactly. Yep, that's easy to forget. Did you guys hear that? Ooh, we have a problem here. We took an even root, and take a look at that. Odd exponent from an even root. That's a problem, isn't it? Absolute value bar.
Has to go around the x to the 5th. So take a look at your page 230, 230. It's the problem 2 got it. What page is that on?
39. Is it 239? So take a look at the problem 2 guide. Let's do this one together. Then I'll have you try a few on your own.
You with me? Cube root of 128
Times x to the 7th.
You know what would be really helpful right now for you guys is to make a list. You guys all know the perfect squares. You've memorized most of those, but what are the perfect cubes? Perfect cubes. You gotta have that list somewhere in your notes. 8's a perfect cube. What else? 20-something. 27 was a perfect cube, because that's 3 times 3 times 3. 64 was a perfect cube. 125 was a perfect cube. 216 is a perfect cube.
Do any of those numbers divide into 128?
64 looks like it might. So you change the cube root of 128 into what times what? 64 times 2, and then the 7th is a problem. 7 is not divisible by 3. So the next smallest number is 6. So we change that into x to the 6. X to the 6 times x to the 1. So, which ones are going to simplify? Which one of these terms simplifies?
64 and x to the 6.
64 and x to the 6. So those are the ones that move out front. The ones that don't simplify stay inside. So what is the cube root of 64? 4.
to the 7.
And then if you take x to the 6 and divide the 6 by 3, you get x squared.
Cube root.
And then we have a cube root of 2x. It's not so bad, is it?
Oh, nowhere else.
Yeah.
Because the exponent is divisible by the index, so you divide the exponent by the index. All right, try problem 3. Practice problem 3 just underneath it. You see where it says A practice? Actually, try 3 and 4.
Go. Try 3 and 4. Where it says a practice. Or maybe it's a practice.
So,
The question 3. 81 is not a perfect cube. What factor of 81 is a perfect cube?
27.
27 times 3. And then x to the third, 3 is already divisible by 3. So we don't need to mess with the exponent. Just keep it as x to the third. Huh? Now, which factors simplify here? 27. So the 27 is going to come out as the cube root of 27, which is 3. And then what about x to the third?
Does it come out as X or just cancel?
It comes out as
Okay,
x
good. So I put
to the first, because 3 divided by 3 is 1, but you don't have to put the exponent of 1.
I was just sure.
Yeah. But we have a term left over on the inside, so that's multiplied by the cube root of 3. So it's 3x.
times the cube root of 3. And again, I don't know why this happens, but every year I get students that think this cube root and this 3 should simplify somehow. Does 3 have a cube root? No. All right, question 4.
This one's a bit of a challenge, maybe because you weren't familiar with perfect fourths. Perfect fourths. Numbers that have fourth roots. 16 has a fourth root, because that's 2 times 2 times 2 times 2. 81 has a fourth root, because it's 3 times 3 times 2 times 3. 256, that's usually about as high as we need to go for fourths. Any of these divide 64? .256 may be a multiple, but what divides 64? 16 and 4, right? So you change the 64 into 16 times 4.
I mentioned this briefly, but you might not have heard it. If the exponent is smaller than the index, you just leave it. There's nothing you can do with it. If the exponent is smaller than the index, then it stays on the inside. You don't have to split it up. So I'm going to leave the x to the third alone. 6 is not divisible by 4, so we need the next smallest number that is. So that's y to the 4th times y squared. All right, then. The 4th root is 16. 16 is going to simplify. That comes out as a 2. The 4th root of 16 is 2. What else simplifies in here? Y to the 4th. The 4 divided by 4 is y to the 1st. But now everything else stays on the inside. So this is going to be the 4th root. 4x to the 3rd. Y squared. There is one tiny little thing we're forgetting. Didn't we take an even root? And it came out with an odd exponent. Y to the 1st, technically odd exponent. What are we missing? Absolute value around that y. These are kind of fun, aren't they? Are we having fun? I'll take that as a resounding yes.
Better than the other stuff we were doing.
Well, do we need another practice problem? Let's move on to the next topic. Now we can actually start multiplying. 2 of these dang old things together. So, turn the page to the problem 3. Got it?
These are going to get a little bit awesome.
Don't worry, we still have plenty of time. Here's the thing. There's two ways you can do this problem. One way might be a little bit better than the other, but you can do it this either way. Here's the first way.
You can multiply it together first, and then simplify. Or you could simplify these both first, and then multiply. You understand the difference? I think in most cases it's easier to simplify each one separately first and then multiply it together. So let's do that if we can.
So let's simplify each one separate. Simplify this, and then we'll simplify that, and then we'll multiply them. So, if we're just looking at that one there, 45? It is 3 times 15, but we need to have a perfect square number. What do you think, Gabby? What? I just assumed you were paying attention back there. 9 times 5 is 45. Why would we want to use 9? Because it's perfect square. So change the 45 into 9 times 5. And then x to the 5th. 5 is not divisible by 2. 2 is the index here. We got to split up. What number just smaller than 5 is divisible by 2? So that's x to the 4th times x to the 1. And then y to the 3rd. That's got to change into what number just smaller than 3 is divisible by 2? Come on. Y squared times y to the 1st. Now while we're at it, let's go ahead and try to simplify this other one over here. So multiplied
All right, think about 35. Not many choices there. 7 and 5. But does that help? 7 times 5. Those don't have any square roots. Anything else multiplied 35 that I'm not thinking of? So what do we say about 35? 35
doesn't simplify. Square root of 35 is just a square root of 35. What about the x?
Yeah.
That has an exponent of 1, which is smaller than the index, so that just stays. I'm going to say a 35 and an x. What's the square root of y to the 4th? So I'm going to go ahead and just put a y to the 2nd dollar there just automatically. So we've already simplified the blue one. Let's go back and simplify the red one here. What happens to the 9? Let's pick this up now. What happens to the 9? 3. And then we're going to have an x squared. And then we're going to have a y. Okay. What are we missing here? There's a 5 and an x and a y. Now we're going to actually hold off on the absolute values until we're done with the entire problem. So we're multiplying now by a y squared times the square root of 35 x. So let me just remind you of the property that you wrote down at the very beginning. If you're multiplying two things together that have the same index, then all you do is multiply the stuff on the inside together. And if there happens to be stuff on the outside, you multiply that together too. So we have a lot happening here. Let's multiply the things on the outside. What are we going to have on the outside? 3x squared. Y to the 3rd. Now let's do the stuff on the inside. What is that? 5 times 35? 175. X squared times y. Oh, dang it.
You just simplify it again. You simplify it again. You gotta take that X out.
All right, take a look at the 175. Is there a number that multiplies to something else to equal 175? If you have $1.75, how many quarters do you have? You have 7 quarters, so it's 25 times 7 is 175. What's significant about that? 25 times 7?
25 has a perfect square, so now we need to do one more teeny tiny round of simplifying. No biggie. Change the 175 into, what did we say it was? 25 times. Okay. The x squared, that's divisible. The 2 is divisible by 2, right? We don't have to split it apart, so I'm just going to leave it as x squared times y. Okay, so what's going to happen with the 25?
Put a 5.
So I'm going to put a 5 out here that multiplies with that 3. And then the x squared. So I'm going to multiply another x right there to that x squared. And after much trial and tribulation and wandering through the wilderness, wait, that's something else. We're done with this problem.
But wouldn't you add the 5 to the 3x?
Well, what is 5 times 3? So we have 15. X to the third. Y to the third. Holy crap. Now we need a couple of absolute values, because take a look, we had an even x, or an even root that had a couple of odd exponents there, so we need an absolute value around x and an absolute value around y. Not on the inside, only on ones on the outside. So it's 15 absolute value of x to the third, absolute value of y to the third, times the square root of 7y. Yeah, that's the plan. Maybe not so easy anymore, are they?
It just takes a while.
Took a little bit of time. Okay, same page then. Let's do the 6th practice. Practice number 6. So we have 3
Times the 4th root of 18, 8 to the 9th. Times the 4th root of 6a b squared. Do you remember how I said sometimes you multiply it first and then you simplify, or you could also simplify first and then multiply? Either one works, but if you take a look at what we have, there's much simplified right off the bat. True. This one might be better just to multiply it first together and then simplify at the end. Let's try it that way.
So we're going to multiply first and then simplify. What about this 3 hanging out over here? Stays in the front. So it's 3 times the 4th root. Of 108 exactly. A to the 10th, because we have a to the 9th times a to the 1st, which is 10a, so a to the 10th. And then b squared. Yes.
These problems are the best. You remember that list of perfect fourths I had you write down a moment ago? 16, 81, 256. Do we need those divided into 108? 27, Mike. But yeah, that would be a perfect cube. So the only options for perfect fours, we had 16 and 81. None of those divide into 108. So what does that mean about 108? It stays 108. That's kind of cool.
So the 108 doesn't do anything, but what about 10? 10 is not divisible by 4. We want it to be divisible by 4. The next smallest number after 10, or before 10. 8. So we're going to change that into a to the 8th times a squared times b squared. We already decided that nothing happens with the 108. That a to the 8th, if you divide the exponent by the index, that's going to become a squared. So we already had the 3, now we have an a squared out there.
108 a squared.
And we have the 108, a squared, b squared.
All right, why don't you guys stand up for just a second? Your butts are going numb. Your brains were numb a long time ago, but now your butts are going numb. Want to hear a funny story? It was 3 or 4 weeks ago during one of these little stand-up breaks. I played a How It Should Have Ended video, but I forgot to stop recording, so the video recorded. And then when I posted that video to my website, YouTube wrote me a mean letter. You had copyrighted material on your video. I totally didn't even realize it. Well, the How It Should Have Ended.
They watched.
They were trying to learn math, and they were watching my video. What's that? Yeah. Okay. We're almost to the halfway point. This is a super long lesson. I'm not even kidding. What was the title of the lesson? It was multiply and dividing. We haven't even gotten to the dividing, which we're going to get to right now. Don't worry, dividing's so much easier always than multiplying, right? Wouldn't you rather always divide than multiply? Because with division, sometimes you end up with cool fractions. That's way better. So,
Dividing radicals. So it's a similar property I want you to write down. The nth root of a divided by the nth root of b.
you can only divide radicals if they have the same index. Hey, kind of like you can only multiply.
If they have the same index. But the property here is if you have two separate roots and they have the same index, that's the same thing as this.
Having one big giant root. You guys gonna be okay about it? I got an empty seat up here for one of you if you need it. It's really, that seat is lonely. It needs a butt in it.
Now, you guys need to realize these properties work both ways. Sometimes it's helpful to go in this direction with the property. Sometimes it's helpful to go in that direction with the property. Okay.
Anywho, what page are we on? 240 now? 240? Or is it 239? No, it's 240. Take a look at 2. No, it's 240. Now it's 241, yeah.
Page 241. Problem 4. Got it? So it asks us to simplify the square root of 50 x to the 6 over the square root of 2x to the 4th. So this is kind of like multiplying, where sometimes it's better to simplify first and then divide.
Most often it's better to divide first and then try to simplify.
So let's apply the property going from left to right. Don't we have the same type of root? So let's write this as one big giant square root of 50x to the 6 over 2x to the 4th. Why would that be such a good move?
This makes this problem so much easier.
So you can't do like cancel out.
You guys know this. I know you do. Don't wait for me to say all the answers. What's 50 divided by 2? 25. If you have 6 x's on the top and then 4 x's on the bottom, the 4 on the bottom cancel with 4 on the top, leaving how many?
There's 2 on the top, right? You learned last year in secondary 2 when you're dividing expressions, you subtract the exponent. 6 minus 4 is 2. So this just turns into the square root of 25x squared. 50 over 2 is 25. X to the 6 over x to the 4th is x squared.
This is probably even farther if you wanted to.
And now, bada boom, bada bing, we simplify that even farther. Square root of 25 is 5. And then the square root of x squared
So equals 5x.
is,
Absolute value.
okay, absolute value of x, because it came out with an odd exponent.
Well, that was quite the journey, wasn't it? Yeah. The what now? Now we're confused. Pause! Anywho. So,
On the middle of page 241 where it says, a practice, or a practice. Let's take a look at problem number 7. Well, now wait a minute. No, this will work. Should we try to do the same thing we just did? One big giant square root of a single fraction? It's worth a shot. But there's one. Oh, there is one little problem here.
I got it.
Okay, you guys watch it carefully. I know it's been a long lesson and we're kind of razzled, but you need to pay attention. You got to focus. You got to dig deep. Sound like that guy from the Insanity DVDs. You guys ever do those? Anyway, apparently not. What's 48 divided by 3? Okay, so we know we're going to have a 16 floating around in there somewhere. So I'm going to put it right here. X to the 3rd, but then we have an X down here.
The x is second.
That's an X to the 2nd. But then the Y squared, it's just going to say Y squared, but where is the Y squared? It's on the bottom right there. Yeah. 48 divided by 3. And then x to the second came from, there was an x to the third right here, but then there was a single x. When you're dividing, you subtract exponents. You guys with me here? I would actually recommend now that we go back to separate square roots, like this. So we combine them to simplify the fraction, but now we separate the square roots
To simplify the radicals. You can go back and forth a number of times in the same problem, doesn't matter.
So what's the square root of 16x squared? 4 times the absolute value of x
And then divided by x.
divided by the absolute value of y.
Tricky, tricky.